Hello class, this is a video tutorial on sketching functions. To sketch accurately and efficiently, we follow the following steps. Okay, I'd read you the steps, but I'm going to do them as we go along. So you can pause the video, copy this down, but I'm going to go through these steps in 3, 2, 1. Here we go. So the first step we need to do is combine the terms using common denominators and factoring fully. So here's our function, f of x equals 2x squared minus x squared plus minus 9. If we somehow had, let's say, plus 1 on x, we'd have to get a common denominator and add these together. But fortunately for us, we don't need to do that. All we need to do is actually factorize this expression here. So factoring, well, 2x squared cannot be factored. And our denominator we can factorize as x plus 3 x minus 3. Okay, that is our factored function. And from this we can actually determine our domain. So from here we can see that we can see that when x here, if x in this denominator here were to be equal to negative 3 plus 3, we'd have a negative denominator. Sorry, a 0 denominator. Because negative 3 plus 3 is 0. And we cannot have a 0 denominator. So we have our first limitation there at x is equal to negative 3. So x cannot equal negative 3. Similarly here, if we have a positive 3 here, minus 3, this group will be 0, leading us to having a 0 denominator. So likewise, x cannot equal positive 3. So our domain is all real x, but x cannot equal positive or minus 3. Okay, moving right along. Our next step is determining the symmetry, whether it's odd or even. I tend to always test my even functions first, right, and hope for the best. So here we go. So our f of x is 2x squared all over x plus 3, x minus 3. Okay, now we're going to test f of negative x. Negative x. Substituting negative x for all x, so 2 negative x squared all over negative x plus 3 negative x minus 3. The numerator now, negative x squared, becomes just 2x squared. And our denominator, we can factor a negative 1 from here. So negative outside of x minus 3. And a factor of negative 1 from this one as well. So times negative x plus 3. Notice how there are two negatives in the denominator that are multiplying. So this will simplify down to 2x squared all over this negative, and that negative will cancel to become a positive, giving us x minus 3, x plus 3, which is the same as f of x. Therefore, this function, f of x, is even. Now this will help us because we now know that there's a line of symmetry about the y-axis. So if we can graph the left side of the y-axis, we can mirror it on the y-axis. Okay, now let's keep moving on. Let's find our y-intercepts when x is equal to 0. So let's find f of 0. Substituting that in, we get 2 bracket 0 squared all over 0 minus 3, 0 plus 3. Well, it's very easy because the numerator is now 0. Everything else will become 0. So our y-intercept is going to be x equals 0, y equals 0. We do a similar process here where we let 2x squared all over our denominator, x plus 3, x minus 3 is equal to 0 because that is our y value. And we solve for this. Multiplying out by the denominator, we get 2x squared equals 0. Dividing by 2 and taking the square roots, leaving us with 0. So our x-intercept is also at 0, 0. Okay, now from these points, okay, we're going to now determine the signs of the function. How we found these points are we need 0 values of x, which we found here. That's our x-intercept. Okay, so we know this is already going to be 0 because this is 0. We don't need to test anything here. And also from our restrictions in the domain. So when x equals negative 3, it's undefined because the denominator becomes 0. So at x equals negative 3, we don't know what happens. I don't put a 0 there because 0 is a value. Instead, we don't know what happens at a numerator divided by 0. Okay, so and also at x equals 3, the same thing happens. So we don't know what happens at those 2 points. Instead, at these points, one below, and a value in between our restriction and the next point, we're going to test. So these are the values we need to test. So now let's get to it. If we substitute negative 4 into this numerator, we get 2 negative 4 squared. Well, negative 4 squared is positive times 2 is still a positive. If we substitute negative 4 into here, so negative 4 plus 3, that's going to be a negative 1. That's going to be a negative. If we substitute negative 4 into here, so negative 4 minus 3, well, that's going to be negative 7, which is negative. Now, if we consider this, we have a positive divided by a negative times a negative, which means our function at this point is positive. Is positive. We don't know what happens here, so we're not going to test it. Let's test the value of negative 1. Okay, so when you substitute 2, negative 1 squared, well, it's going to be a positive value. If we substitute negative 1 into this point here, plus 3, it's going to be 2, that's going to be positive. If we substitute negative 1 here, negative 1 minus 3, that's going to be a negative value. So this is going to be negative. Looking at these factors, positive times negative, well, that's going to be a negative value. Here we know it's going to equal 0. Now let's test once again for positive 1. So 2 times 1 squared, positive. Substituting a positive here, 1 plus 3, that's positive. And 1 take away 3, it's going to be negative. Looking at all these values, these factors now, positive times negative, that's going to be a negative value. We don't know what happens here, so we're not going to test it. Now, because we know f of x is even, you can see that there's a symmetry already forming about the 0, right? At the y-axis. So without even testing, I already know this is going to be positive, that's going to be negative, that's also going to be negative, which will give me a positive of 4 because it is symmetrical about the y-axis here. Okay. Next step we need to do is calculate our vertical asymptotes, our horizontal asymptotes, and then from all of this we're going to graph the functions. Our vertical asymptotes have actually already been determined for us. Our vertical asymptotes are when the denominator, right, is undefined. So we actually have two vertical asymptotes at x equals -3 and y equals, and x equals 3. Those are our vertical asymptotes. As for our horizontal asymptotes, take a look at our function f of x equals 2x squared all over x squared minus 9. Okay, and we're going to divide through by the highest power of x. So dividing through, we get 2x squared divided by x squared, that's the numerator, divided by x squared divided by x squared, that's this first term, minus 9 over x squared. Now we test as x approaches infinity. Oh wait, sorry, I forgot one more step. We need to evaluate anything first. We'll simplify. Oops. These two will cancel, leaving us with 2 on the numerator. These two will cancel, leaving us with 1 minus 9 on x squared. And now we can let x approach infinity. Now at this point, take a look at what happens. 2 and 1 stay the same. 2 over 1. 9 divided by a very large number is 0. Leaving us with just 2 over 1, which is 2. And this is going to be our horizontal asymptote of y equals 2. Now putting everything together, we're going to come up with this. We need our Cartesian plane. It's my x, it's my y. I know there's a vertical asymptote at -3 and +3. So here's my -3 here. And my +3, +3 here. Now for a vertical asymptote, we draw a dotted line like so. There we are. And also we have a horizontal asymptote at y equals 2. Let's draw that in approximately here. There we are. And now using our signs, right, the sign table, right, we're going to get our values here. So between -1 and 1, take a look, it goes from negative to 0 to negative. So here's our 0. At -1, it is negative. And then at +1, it is negative again. So from negative to 0 to negative. So really, our equation, because also this is an asymptote, our graph will look something like following. That's between 3 and 3. Okay. And now lastly, at this point here, automatically if in case you haven't seen these before, are asymptotes here as y approaches infinity, the x value approaches the asymptote like so, and the horizontal asymptote does similar like so. And this is mirrored on the other side like so. Here's our graph of f of x. Oops. F of x is equal to 2x squared all over x squared minus 9. So I hope that gave you an insight into graphing these functions. I know it's a long process, but I hope you saw an insight into graphing these. See you in the next video. Best of luck.